Thank you everyone for attending another Softcrylic webinar. My name is Sammy Anderson. I'm our marketing coordinator here. Today's webinar, we're focusing on audience modeling for digital marketing. We have a group of really great talented data scientists, advanced analytics, digital analytics consultants here. I'll pass it off to Brad Kosman. He'll get it started.
Sammy, thanks for the introduction. As Sammy mentioned, my name is Brad Kosman. I lead the data science and analytics practice here at Softcrylic. And we've got a really interesting topic that we want to talk about today. So we called audience modeling. And I'm going to give a brief overview of the team, what we mean when we say audience modeling, a couple of the approaches that we use for it. I'm going to hand it off to Sam and Vignesh, a couple of data scientists on the team, to talk in a little bit more detail about how we approach these types of problems. And then at the end, we've got some really fantastic case studies that the rest of the team is going to walk through with you. So first off, a little bit about us. We are the data science and analytics practice. We are analytics generalists. That means we do everything from reporting and light ETL work all the way up through building machine learning pipelines and building algorithmic products, primarily focused on digital marketing. So things like algorithmic attribution, of course, audience modeling, what we're talking about today, making product recommendations and personalization, anything along those lines we cover. And one of the more common use cases, applications of data science across pretty much universally across our clients that we've come across in about the last year is this concept of audience modeling. The idea here is that you as a marketing organization likely collect tons of different types of data on all of your customers. So demographics, on-site behaviors, digital marketing data, and transactional data, anything you can think of, you probably collect it. And generally speaking, a lot of times what happens is you'll define an audience based on lifetime value or based on how many premium products they bought in the past or some unidimensional kind of characteristic of a person. But ideally, you'd like to use all of your data, right? You already have a fairly holistic 360-degree view of each of your customers. So why not leverage all of your data? So there are a couple of different ways that we can do this, and we approach this. One is sort of a predictive approach where we take an individual and we try to see what their next move is going to be. We call that predictive analytics. I'll get into more of that in just a moment. And then the other way that we approach this is to define entire new audiences, entire new segments, clusters. Those are all synonymous for the purposes of this presentation. So in practice, what this looks like is you gather up all of your data. Most of the time that's already complete, right? You have a data lake or data warehouse with all of your customer data stored. Then we apply some sort of machine learning algorithm to your data set. And then the outputs are either sort of propensities, so predicting somebody's next behavior, or new audience segments, right? From there, you effectively have marketing lists that you can approach your audiences with, right? So you can either activate on that data through your DMP, you can build an email list, or of course, upload directly to various marketing platforms. So I mentioned on the last slide that there are basically two different problem sets, right? There's the predictive type of problem set, and then there's the audience defining type of problem set. There's a little bit of serendipity there because those two basic marketing problems map very nicely onto the two branches of data science that we're going to talk about today. One of those being prescriptive analytics. This is like the propensity modeling and predicting next behaviors that I mentioned on the last slide. And the other is descriptive analytics. And that's really what we'll be focusing on in the case studies. It's more about taking the entirety of your data and trying to distill out very specific patterns that would be hard to figure out without some sort of help from machine learning. What this allows you to do is to identify distinct groups of people, distinct segments that are behaviorally unique amongst your set, or they have some other hallmark characteristic that will allow you to target them with very tailored messaging, or build a marketing strategy based on what you think they want, right? What you think their various preferences are. One last way that I would recommend slicing this, especially as we get into the case studies, just to stay oriented here, is to think about everything in terms of data inputs and data outputs. So your inputs, as we've already talked about, are going to be things like demographic data, behavioral data, transaction data, things like that. And then on the output side of things, of course, you can get various lists or propensities. Now, depending on what input data you can have different types of outputs, right? So if I don't have on-site behavioral data, on the input side, I obviously can't have that on the output side of the algorithm. But what you'll kind of notice throughout the case studies and what sort of differentiates them is that we have different types of input data, and that allows us to do different types of things on the output side. So just think of this slice as a very straightforward way to stay oriented about, okay, this particular problem that we're dealing with here calls for this very specific type of data on the input side, because that'll allow us to do very specific things with the outputs. So that was a very high level overview of what we're going to be talking about. I'm now going to hand things off to Vignesh, who's going to talk about prescriptive modeling. Again, this is the sort of predictive side of things, trying to figure out what somebody's going to do next. So Vignesh, take it away.
Hi all, welcome to the supervised session part of the webinar. So supervised learning is the most common sub-branch of machine learning today. So supervised machine learning are designed to learn by example. As the name suggests, supervised, to train this algorithm, it's like having a teacher or a supervisor who oversees this whole process. So to train this algorithm, we need labeled data. So or already a part of the data is tagged with the answer correctly. Or in other words, we are trying to map the input to the output correctly. So let's take an example from the digital marketing world. So let's say we ran a digital marketing campaign last week, an ad campaign for launch of a new product. So we already have the list of targeted customers who clicked on this ad, and list of targeted customers who did not click on this particular ad campaign. So now we have the labeled paired data set. So using this data set, we are going to train the model. So when we train the supervised model, this algorithm is going to search for patterns, which is going to correlate the patterns with the desired outcomes. In our case, the desired outcomes is the target variable, the yes or no. So, and the input variables, the age, gender, hobbies, and location, and other details regarding the customers we have in our database. So these input data sets are called predictor variables, and which are used to predict the target variables, the desired outcome, yes or no. So where can we use this supervised learning? So we can use this supervised learning to automate time consuming or expensive manual tasks. So one of the classic examples of is doctor's diagnosis of an malignant tumor. So like we have a lot of scan images of these tumors, as well as a lot of medical reports and data regarding the patients, so which are labeled. So based on this, like we can have a classifier which classifies whether a particular tumor is malignant or not. So if we, this is very time consuming and expensive, but with a supervised model, like we are able to automate it very simply, and it is very cost effective. And another example, which we just saw, the customer, whether the customer will click an ad or not. So to do all this, we need labeled data. So where can we get this labeled data? So one straightforward answer would be the historical data with the labels. So if we have the past campaign data, or if we have something done which is stored in our database past, we can have the labeled data extract from it. Or if we don't have this, if it is a completely new process, we do not have it, so we can go for an controlled experimental methodology. So one of the common experiments known to the digital marketing world will be the A/B testing. So like we are all aware of it. Another way of getting the label data is like crowdsourcing label data. So like we might have all aware of CAPTCHA, or when we sign up for any Google services, we will be asked to click the pictures of trucks. So like for image recognition and for natural language processing, like these crowdsourced these CAPTCHA methodologies are used to do the crowdsourcing label data. So let us use a simple analogy here, like how supervised model is going to help our business. So an industrial revolution helped us move from 1 horse to 1,000 horsepower. Similarly, this supervised ML model is going to help us move from 1 brain to 1,000 brain, which work simultaneously to answer our business problem or business question which we are trying to answer. So if you ask me, like, we have humans, like we have the data set and we have the answer, like why we need to go to a machine to answer or solve our problem. So when we have 1 or 2 dimensional data or few features, it will be easy for us to identify the relation or pattern. When we have, say, hundreds and thousands of features and tons of data to analyze and to find the relative pattern which correlates to the desired outcomes, where this simple machine, which is good at doing this particular task which we train for, which outperforms in human and which is cost effective. So like that's where the trade-off is between the human and then supervised ML model. So to leverage and potential supervised ML, like any digital agency or an organization need to have uh, 4 elements put in place. So first you need to have the right questions, like what metrics you are going to forecast or what potential behavior of a customer you are going to predict. Second, you need to have the right data. In terms of data, I think like we have come so far long. The 90% of the data which is available in the world are produced in the last 2 years. Even though we have tons of data, we need complete and clean data to answer the question which we are trying to solve or the solid hypothesis which we are trying to test. And third, we need the right technology in place. Suppose if we have data in different places, in different platforms and different formats, we need to integrate and we need to activate this data. So we need the right technologies and tools to solve the business problem. Fourth, you need the right people. So we need the data engineers, we need the domain marketing expertise, we need the data scientists to work in hand to solve the business problem. So let us see some of the common use cases, or in our term, the question which you are trying to ask. So how likely is a person on your website to buy a product or a service? Or how much is a customer is likely to buy this year? Which one of the customer is going to stop using the product or service soon? Or predict the customer's lifetime value. So these are some of the use cases or some of the questions which you can answer, get answer via using supervised machine learning model. So if when we look at the previous slide, when we look at these questions, like these are very common terminology. The point 3 which we look is our churn modeling. The fourth one, customer life cycle value, or the first one, if you look at it, is called propensity scoring. So these are some traditional business problems or questions which we are trying to solve using a supervised ML model. So now we are going to see one of the use cases, that is the propensity modeling. So propensity model is a statistical scorecard that is used to predict the behavior of your customer or a prospect base. So before going deep into propensity modeling, so let me say, like if you run an ad campaign and let's say you have an 1% click-through rate, we doesn't know like why the rest of the 99% did not click your ad or view your ad. It may be due to wrong targeting, or it may be due to ineffective strategy. So to improve your ad targeting by using supervised ML, you can, to reach out to the right audience at the right time and the right location, we can use propensity modeling. So we can target the relevant audience segment who has the propensity to buy your product or to willing to do something which you are targeting for. So in our example, let's say we take an ad campaign. We want to see which are the which are the potential customers who are willing to click or participate in this particular ad campaign. So let's say we have the customer's interests, age, location, email clicks, page views, his social media activities, his likes and don't likes, and we have tons of data about the customer as well as in the past whether the particular customer has clicked or not. So again, we are going to train an supervised algorithm model. Let's on this data, and this algorithm is going to search for a particular pattern, which is going to correlate to the desired outcome, whether he will click on particular ad campaign or not. So based, these algorithms will automatically score each customer. So from this scoring of this customer, we can find the most relevant audience and we can target them. So we need not target unrelevant audience like who has a pretty low or a medium level score. We can target specifically who has the propensity to buy, or who has the propensity to participate in our particular ad campaign. Next slide. So once the propensity scoring is done, that we can target consumers who have high propensity to convert, and with these insights, we can build a 360-degree profile of a customer, so that we can target them effectively. So once we build this lookalike audience, so we know like which are the audience who are will be effective via this particular campaign, who can be targeted via a particular channel, who will be buying the service through one text, who will be buying and service via subscription of an email. If we have all this information, we have multiple platforms to target this types of audience. So like we can create a lookalike audience and target them accordingly. So if we have all this in place, like we can have improve our return on ad spending, and can improve our revenue. And moving to Sam for unsupervised learning.
Thanks, Vignesh. I'm Sam Steyer. I'm a data scientist here at Softcrylic. Thanks, Vignesh, for giving us an awesome breakdown of supervised learning and how it can be used to generate propensity models, as well as be used for targeting different audiences to find the most effective members for any given campaign. But opposed to that, we have on my side of the equation is unsupervised learning, where a great distinction between the two is with supervised learning, as Vignesh alluded to, you need labels and you need to have kind of a target which you're trying to hit to maximize the propensity of your data at hitting that target. And the algorithm really is searching for those different features, those different data points that it can use to leverage to find what's going to maximize the propensity at hitting that label, at hitting that target. Unsupervised learning is really doing the opposite of that. It's really searching for patterns and different types of interactions in your data, which might not be present to the eye. It doesn't have labels which to work with. Instead, it's really searching your data for the patterns to group or cluster or even reduce your data into sets of information that really go well together. And in the case of this presentation, we're going to be talking a lot about how it can be used effectively to merge your data into clusters or groups or segments of data points that can be representative as audiences. So with clustering Softcrylic, we can generate all sorts of different dynamic audiences. Clustering via machine learning offers the unparalleled ability to look for previously undetected patterns in a data set with no pre-existing labels and with a minimum of human supervision. This is really ideal for creating dynamically those different audiences or personas. You don't even need any information about what those groups may fit into. You don't need to work with these pre-existing human heuristics. Instead, we're using these algorithms, these clustering algorithms, which we'll go into more detail in the next slide, but we're using these algorithms to really search for those different undetected patterns in order to separate them into those distinct groups, which makes it much easier for then a human to come in and then say, hey, this group really has these distinct descriptive characteristics that we can use to kind of identify this group has these distinct patterns unique to them. And then we have this other group that the algorithm was able to find that clustered out that has another group of characteristics of data points or behavior that make them different as well. And with those different clusters, we're able to really effectively target in campaigns as well, just like with supervised learning. But you're allowing yourself to find, gaps in your audiences or the distance between two clusters or two groups of personas that allow you to more distinctly determine that these are different sets of your customers, different sets of audiences for you to more effectively target. And with that, let's go into a little bit about like the different families of clustering algorithms that really exist. So I really like to think of clustering falling into three distinct families of algorithms. And it's really, really critical when you're going about performing this to generate your audiences that you're really finding the right clustering algorithm to solve your problem. As you can see below, there's just three families that I kind of spoke to. There's the centroid clustering, the density clustering, the graph-based clustering. And as you can see below in these graphs, there's some key differences that can appear when you're not necessarily relying on an expert to really identify what's the best one to attack your distribution for your customers. So I think one of the best ones is if we look at the bottom row, we can see that the density clustering, because of the way it works, it's really looking for blobs of data, dense clusters of data points. It's really seeing that huge block there as one cluster. And that's a really common trap fall for somebody to walk into if they're really unfamiliar with how these algorithms work. Where centroid and graph are really kind of producing, despite the different kind of color wheel that's occurring, different clusters, but they're still finding three groups that are relatively similar. So it's really important when you're going about this to really understand and do some exploration independent of the algorithm itself going about and finding the different clusters, right? So I think another great example that we have here within the different families is the top one as well, where we can see the density clustering is finding two different distinct clusters and the graph is finding three distinct, and then the centroid is kind of finding like one distinct and maybe two that aren't really that distinct. And I think, when we're going about building audiences, when we look at the graph one, that's really what we're aiming for. We're aiming to find there's really three distinct pockets of data points that are being produced to find those different clusters. And what we need to do when we're working as a team with marketers is we need to kind of come together and make sure that we're explaining exactly how these different kind of black box algorithms can really affect the downstream product of your audiences. And these algorithms are incredibly powerful. Their ability to separate data into those distinct audiences is immense. They're incredibly effective at it. But without expert guidance, sometimes you can kind of walk into rabbit holes you didn't know existed, like on the bottom row with the density clustering. But that's not all unsupervised learning can really provide. It can also provide what's called dimensionality reduction. And dimensionality reduction is an incredibly important technique because what it offers is the ability to squeeze down a set of data down to the unique combinations of information that defines your audience. And this resulting data is of significantly smaller size. But it contains roughly the same level of descriptive information, which a clustering algorithm, now that it's squeezed down to just what's important, is more effective at segmenting those into different groups or into different audiences of your customers. We just have so much information now about our customers and about the people who are going onto your website, your mobile application, or even just your point of sale locations. And with dimensionality reduction, we're able to kind of remove those overlapping characteristics and metrics or behaviors, and we're just squeezing them down into just kind of sets of information that is just unique representations of your customers, right? Instead of having three things that are describing the same information about your customers, now we're only going to maybe have one thing that's going to describe it, but it's kind of like a meta characteristic. It's going to have information from all three different characteristics squeezed down into one. And a great metaphor for this is really a map, right? If you think about when you go outside and you kind of explore the world around you, there's all sorts of different characteristics that you can really see when you're going about walking through your city or your hometown. But when you really reduce it down to just what's important, You don't have things necessarily about elevation on your Google Maps or Apple Maps. You really just have a much reduced set of information that's just what you need to get the directions you need to get from point A to point B. You don't necessarily need the elevation or the color of the buildings or like what type of walking paths are there if you're in a car. You really are just worried about how you can get to point A to point B in your car. And that's really what dimensionality reduction is doing with your data for your customers. It's just reducing it down, boiling it down to just the information it needs for the algorithm to separate them out into different audiences. And this has all sorts of different advantages. It allows the algorithm to more effectively separate things now because there's just so much reduced noise. There's not as much complexity in the data. It's just what it needs to separate. It also reduces the computational time it takes, which reduces the cost of your data science teams in order to produce those different audiences for your marketers. But I don't think that's all that we're gonna go into. I think we have some great examples coming up here in a few minutes with Morgan leading the way in terms of how we've actually gone about applying this for our different customers. And there's some great case studies that they're gonna go into that really describe the different practical instances of both supervised and unsupervised learning that we found to be really effective for our customers and have produced some pretty great results. But I'm Sam Steyer, and I'm going to pass it off to Morgan DePietro right now.
Morning, everyone. My name is Morgan DePietro, and I'm an advanced analytics analyst here at Softcrylic. And we're going to go into a use case today about how we use some of our persona modeling to help run a really effective campaign with one of our clients in the airline industry. So Sam actually set this use case up really well. In this one, we're going to look at a use case of that unsupervised clustering. And we'll see how we let the computer make those choices and those groups that it needs to make. But we're going to take all of that information back and review it with a lot of marketing experts. And you'll see how that process works here. So there are really 3 steps to setting up an experiment like this. So first, we're going to identify those high propensity or high value, marginal value customers. We're going to do that in large part through these clustering methods. Then we're going to take those customers to market and target them in some sort of experimental design setup. And then we'll measure those conversion outcomes from those targeted ads. So within that identify high propensity customers, here now we really have 3 steps. Okay, first we're going to collect that customer level data. We want customer level data from, basically every spot in the organization that we can get it. So we'll take a lot of that enterprise data, maybe point of sale, revenue sort of data, first party enterprise data. Then we'll take a lot of digital data, whatever digital stack you're on, whether it's Adobe, Google Analytics. We'll start getting some customer level data out of those sources. And then we'll go ahead and run our unsupervised clustering. A lot of those model types that Sam and Vignesh were talking about. And then we'll go ahead and identify those personas. And the identifying personas is the part that really takes some sitting down. And it's quite a bit of art and science. So we'll see how that works. So this is kind of a depiction of how that clustering is going to work. We're going to take that enterprise data we talked about, maybe it's demographics, revenue, certain product profiles, membership status within your organization, and then that digital data, so things like page views, email clicks, time spent. We're going to accumulate as much data as we can about these customers so that we can really create an accurate and highly segmented proper group of audiences. Then we'll move that over to the clustering, all that data. That clustering is going to minimize those differences within the groups and maximize the difference between groups. And now hopefully we're going to see some pretty distinct audiences that we think have a high chance of purchasing these premium products. Then once we have the outputs of that, we're going to take that to the strategy team, analyze those results, and define those personas to identify the best audiences for testing, whether they're going to be the most receptive to this messaging or kind of are what we think are the highest marginal value customers. So let's think about this use case again for a second. So this is we did this for a client in the airline industry. We're looking to sell some of their more premium products, okay? So this is what the outputs of that clustering method might look like when we take this to the strategy team. So you can see we've kind of got 4 distinct groups here, okay? And we've labeled them, okay? Reliable retirees, sophisticated savers, trendy travelers, prudent patrons. You can see how these customer groups are pretty different. So those reliable retirees, they are already buying about 72% of their products in premium, okay? They've got about 50 web sessions and their ages are between 42 and 64. So these are some statistics that clustering output would generate. Once we take all the customers, we'll average a lot of, very important statistics like this so that we and your strategy team can get a good feel of what this cluster looks like. Okay, then kind of from these statistics, we will make a persona. We'll define a profile on them. So these people were frequent flyers. They're really pretty highly engaged in marketing. They've probably been with a member with the organization for a long time, mainly older retirees, and they already have a really strong premium behavior. Okay, we'll move over to the sophisticated savers. They're buying a little bit less of their products in premium. They're still about as engaged as the reliable retirees in digital channels, but they're quite a bit younger. It looks like in this profile we have a lot of lapsed rewards members. They've saved a lot of those rewards points. So we could maybe be looking to get some of those off our books. A lot of kind of second tier members, they show some market engagement and they've been with us for quite a while. Now we have another group that was output, the trendy travelers. So they're buying a little bit less of their products in premium. There's probably a really good chance we could get them to buy a little bit more in premium. They're extremely highly engaged in marketing channels. You see we have about 150 web sessions per year for them. And they're quite a young group, the youngest group here. So their profile, they're the youngest group, really strong marketing engagement, a lot of kind of second tier members, and they do have some proclivity for premium. At a premium mix of 31%, we would love to kind of bump that premium mix up. And then we have our prudent patrons. Now this, it looks like is what the clustering algorithm did here is the premium mix 6%, small amount of web sessions, and a really varying age range here. So this is kind of a cluster that was not defined as well. This is kind of a cluster that the model placed a lot of members in, and it's a little bit vague. Really, they have minimal flight behavior, very weak engagement in digital and marketing channels. So we would kind of say, okay, the prudent patrons, we don't think that they're a great group to target. They really show very low premium mix. Are we really going to be able to bump that up? Also, the reliable retirees, their premium mix is already very, very high here. So we may not be able to get that any higher. They're really our highest group. The marginal benefit of them seeing these ads and buying a little bit more premium doesn't seem so high to us. And they're already very frequent flyers and loyal customers. So we probably want to go with them. Maybe we would pick the sophisticated savers and trendy travelers after looking at these statistics and kind of developing these profiles. Trendy travelers are young. They do have some proclivity for premium. If we could get them to buy those premium products now, maybe they'll stay with us for a long time and become very high value lifetime members. The sophisticated savers, they certainly have a lot of kind of rewards points booked up, and maybe if we show them some ads for premium products, they would be willing to buy them. So we would go ahead and pick two of these two groups probably to run some tests on. And that's how we take all of this data back, kind of digest it with our clients, and pick those audiences we think are going to be most receptive or provide the highest value. So is what we'll do now. Now we have two groups, okay? We're gonna go ahead and split both of those groups into a test and control group. So is what this client wanted to do. They really wanted to test two different kinds of messaging. One of the messaging was kind of more of a hard sale. It was, hey, buy our expensive product now. The other message was a softer, kind of more luxurious messaging. It was more like, hey, you deserve a premium experience. You should try this product. So once we split those test and control groups, we'll kind of analyze how they look today. It turned out after we got those test and control groups out, most of those metrics that were really important to the business, the test and control groups showed very similar activity in those metrics. So when we see something like that, so you have a test and control group that both spent the same amount of revenue last year, both had the same amount of flights, they're kind of both the same tier members. So we see that those test and control groups are basically the same persona, okay? Now when we expose them to this messaging, we can feel confident that we can measure the effect of that messaging. The only thing different between these two groups now is essentially the messaging that we're showing them. So now, once we've kind of ran that experimental design between those test and control groups within those two audiences, we are going to take a look at the outcomes. In this case, the outcomes really were pretty good. The test and control groups realized statistically significant increase in premium purchases overall, about a 1.7% increase in upgrade to premium products, a 2.1% increase in upgrading via rewards, those rewards points that we talked about, like that the sophisticated savers had on the books, and about a 0.7% increase in premium tickets purchased. So, this is a really great case study for any kind of experimental design. It can be done in a lot of different ways, not just the messaging. So you see that just those two bits of messaging, there was, they were different. They were quite a bit different, not incredibly different, but we were able, with these very well-defined audiences, to measure the outcome in that difference. So really what drove those outcomes is that careful marketing strategy and execution, and that advanced digital marketing science that helped guide and then measure that strategy and execution. So thank you very much. We're going to move on to Josiah for another case study.
Thanks, Morgan. So I'm Josiah Martin. I'm an advanced analytics consultant here at Softcrylic. And mine kind of involves a little bit of the supervised and unsupervised learning. So it's going to be a little bit different in that sense. It's also going to be walking through kind of this idea of a campaign similar to Morgan, but kind of part of that messaging is going to be a little bit different in that there's not already an end goal in terms of what they're trying to kind of sell. It's going to be a little bit more determined on what we see in terms of the audience bases. So specifically, we're going to get into kind of brand affinity and personalization within that space of those particular advertisements. So I think one thing that's important to note now is kind of the sophistication of corporations. It's very rare nowadays that a company offers only a single service or product. And so rationally speaking, it's not really, we can't really assume that everyone has the same preference and the same product affinity within their consumer base. And a lot of companies have this age-old belief that their target audience, they know what they desire, and they know exactly how to get them to purchase. But in reality, it doesn't always align with how things are, right? And with all the data that we now have available, it's important to kind of take a step back and to think about marketing and approaching marketing from a data-first perspective, right? Rather than assuming what we've always believed to be true about our audiences, why don't we go ahead and prove that? Why don't we let the data kind of reveal to us what we know and what we can find out and discover about our engaged consumers, and let that go ahead and shape the way that we then market and target consumers specifically. So this is precisely what persona indexing and machine learning kind of allows us to discover. And in the next couple of slides, I'm going to walk through a case study where this approach was implemented. So in this case study here, we're going to take a look at an imaginary company, Ooda, and they're in the hospitality industry. So they're an international hotel chain with multiple sub-brands or subsidiaries who each kind of have their own target audience, right? So based around things like budget or location, or the amenities that the particular customer prefers. And in this case, Ooda has decided they really want to hone in on two of their brands, Hamra and Bida. And they want to launch an ad campaign to drive consumers to their brand site, and it obviously eventually results in conversions. So the big piece here is deciding which of the two brands that the consumer has the greatest proclivity for booking with, and then going ahead and serving them an ad around that preference. And then of course at the end, in order to kind of measure those outcomes again, we aligned with the business on measuring the click-through rate from the advertisement, and then of course overall bookings in the end. So the first part of the process is really twofold. So the first part is going to go back a little bit to what Vignesh was discussing earlier. We need labeled data in this case, right? We had 120 million site visitors here, so we had a lot of data in terms of people actually coming to the site. What we didn't have was a lot of conversion data, right? And so as you see here, we only had about 500,000 of those 120 million site visitors who actually had transaction history with us. And so that's kind of the first piece there. And then secondly, we need to use the data that we have and that labeled data that we're going to get in order to train a supervised machine learning model, right? Which is going to then allow us to kind of discover those preferences for the remaining 119 plus million site visitors. So in this case, the outcome that we're really interested in, right, is, again, as we discussed at the beginning, we want to know whether a customer has a greater proclivity to book with Hamra or with Bida. And again, we only have about those 500,000 where we've actually seen that transaction history. So based on this purchase history and a few other elements, we crafted a systematic way to basically determine the preference for these 500,000 visitors and label them basically as either having a Hamra affinity or a Bida affinity. And then the second portion, right, is then using, like we said, that label data. So the user plus their characteristics, especially digital data and what they're doing on the site. And then that affinity, which we've just discovered for them, right? Affinity for Hamra or Bida. And then we're going to go ahead and use that to train the model. And this model is then going to be able to tease out, right? What are the most important determinants for being someone who prefers Hamra or someone who prefers Bida? We can go back one slide. Thanks. And then the next step in the process is to use this trained machine learning model, right, to go ahead and predict the brand preferences for, again, that remaining 119 million site visitors. So this visual here is kind of like a high level representation of what this process looks like, from actually getting to, from the place of unlabeled data, right, this data we don't know what that outcome is going to be, whether they prefer Hamra or Bida, and then feeding it through that machine learning algorithm in order to get that output or that label for them. So starting from the left, really the first piece is we're going to limit to site visitors who don't already have that established brand preference. And the data here has been simplified just kind of for the sake of illustration here. So let's suppose that we really only have 5 variables here, right? So 2 pertaining to gender, either male or female, 2 pertaining to favorite color, and then 1 related to age. And so you can see in the first table here how our 2 users, user 1 and user 2, differ, right? So user 1 is a female, older than 20 years of age, and her favorite color is red. User 2, by contrast, is a male under the age of 20, and his favorite color is green. Again, why a boy under the age of 20 trying to book at a hotel room? It's beyond me. I don't, but it's besides the point in this case. Clearly, the important thing here is there are some observable differences that we can find between these 2 people, right? And it's up to the model now to determine what that tells us about their brand preference. So the next step is going to be feeding the data into the model, right? Where it takes all the data for each of those rows and what it knows about those users who have already converted, right? And we use that in order to train the model, and it makes a determination. And then in that final step on the right, you'll see that the output is the same set of traits that we pushed into the model, along with 1 new column, right? This is the prediction for the preferred brand. And in the next slide, we'll kind of touch on what the next step is. So the last step of the process is going to be similar to what Morgan was talking about, right? It's actioning on these predictions that we've made about consumer preferences. In this case, the brand affinity, right? So we've established two distinct personas in this case, those who prefer Bida and those who prefer HIMRA. But this is kind of the piece that's a little bit different than Morgan's in the sense that now we want to take a look at those two distinct personas and kind of look at the summary statistics in the same way, but kind of look at what that can reveal about the characteristics that are specific to each of these users, these user bases, which can be incredibly useful kind of for crafting that content and messaging around this marketing campaign, right? So again, reframing that marketing to be focused on that data-driven approach, right? We're not going to assume HIMRA customers are this way and Bida customers are this way. We're going to go into the data and see what it has to say for us. And then finally, after we kind of have that greater, again, understanding of the data in our particular user bases, that we're going to need to break it up, right, into A/B or ABN tests, right? We could have several variants, or it could just be a single one, as it was with Morgan's case. And we're going to have to serve them different content, right? So the bulk of the users in this case should probably receive that specially crafted message, which is based around what we've observed about them and their preferences. But then we should also have that control with a more generic message, or even an ad maybe crafted around the opposite persona, right? Something that serves someone who prefers HIMRA, a Bida ad, and see if we do actually see that there's a decrease in that click-through rate. And then this way we can then determine the most effective ad if we ran multiple variants, and also whether there's an overall lift based on, again, serving them an ad that's preferable to them. So this final step for this client we have not yet completed, but we do hope to be working on this soon as kind of that next step with our client in the coming months. And then one additional note is just that if you want to know more kind of about this particular case study from start to finish, then I've linked there to this full case study, and kind of walks through the process in much greater detail from pulling the data all the way up to the activation phase. So that's all I've got for you. And now I'm going to go ahead and hand it over to Brett.
All right, thank you very much, Josiah. My name is Brett Crawford. I also work in the data science and analytics practice at Softcrylic. And this case study I'm going to talk about involves segmentation using on-site data, so behavioral data from your users. So this behavioral data is incredibly valuable that you collect from a user's interaction with your site, because it's a direct interaction with your brand that you could then target for marketing purposes. So you can use this data to build segments, new audiences from scratch, which is kind of what some of the other case studies have talked about. But the unique aspect of this particular case study is that we used it to sort of analyze and augment the quality of some existing segmentation. So it can also become a diagnostic tool. It doesn't have to be an effort from scratch. So this client used on-site behavior from users to bucket them into different audiences. These audiences are based on medical conditions, and they are then resold to third parties. So our goal here was to look at their existing segmentation and see if there was any ways to improve it. So in this case, the data we had was for any two segments. We knew the population of people, the number of people who fell into both segments. So in this particular example, the goal was to segment people into different audiences, which were distinct groups, which you could then target with different strategies. So in this example, if you had two audiences, which were essentially the same population, it was kind of an inefficient way to do it. So again, the information we had was essentially for any two segments, the number of people, the population that was in both segments. So if you keep in mind this sort of overlap of the Venn diagrams as we move on. So this is a heat map where each square is a center area of a Venn diagram between two segments. The segments are on the X and Y axes respectively. And so if a square is lighter, it means there's a high degree of overlap between two segments, where a darker square is lower overlap. So dark squares is a good efficient segmentation. A lighter square is an inefficient one. And even with a limited amount of segments here, I think there's around 100, you can already tell that maybe there's some patterns here, but it's just too complicated to look at and figure out visually. So our task here was to take this data and try to find an algorithmic way to solve this problem that can scale up to thousands or tens of thousands of data points. So to kind of explain the methodology, an analogy is a trope from some of the old movies where a detective would put up on a bulletin board different subjects or newspaper clippings with strings in between them to indicate connections. And the goal was to try to find visually some structures between the different entities. So it's kind of, in a way, this is a descriptive approach, but it's the way to think about it is kind of that old trope. So the way we modeled our data, where each suspect or each individual, in the terminology of network analysis, it's called a node, but each one of these nodes was a different audience, where the string between them was the degree of overlap between the two segments. And so another interesting thing here is just the different ways you can represent your data. So after filtering out those connections which were very low overlap and plugging this into the algorithm, and then visualizing it, you can see very easily some communities of different segments that overlap. So, for example, what was labeled community number 4 in the center, these are all segments that are different audiences, but they share essentially the same population. So these are segments that can be condensed into a single audience for more efficient marketing purposes. So it's really easy to see in these visual examples, but again, I just want to stress that this scales to thousands, tens of thousands of different data points. So looking at one of these communities that the algorithm found, you can see it's all different types of cancers, but it's essentially the same audience in each of these segments. So this is one of those things that can be consolidated. And while here it's really clear as to why this audience is all these different audiences is essentially the same population, sometimes this can also reveal really interesting commonalities between different segments and kind of recommend new ways to segment your audiences. So to illustrate the power of this, this is the previous heat map. We've reflected it about the axis, so it became a nice rectangle. But after sorting this by the different communities assigned by the algorithm, you can really easily see how the algorithm found these distinct communities of overlap that really was not obvious just to the naked eye. And so the results of this one is where each one of those segments would potentially be an additional source of marketing spend in your campaigns. By consolidating all these different segments into a single one, you kind of eliminate all these redundant sources of marketing spend. So you can sort of focus your efforts on the unique audiences instead of sort of hitting the exact same people. And so the conclusions from this particular case study, obviously, the way a user interacts with your site is incredibly valuable in terms of marketing. And when you are building your audience segments, it's important to consider both the size of it and the quality of it, right? You want to make sure that you're efficiently segmenting your audiences based on whatever your business needs are. And additionally, there can be time components to where you want to make sure that the structures of your audiences are constant over time, and if they're changing, why are they changing? And finally, that some of the earlier case studies focused on ground up audience building efforts that took large amounts of data, but it doesn't always have to be a ground up audience. You can use your data to improve any existing segmentation you already have in place.
Very cool. Thanks, guys. So I hope everybody was able to see how some of these use cases might apply to some of their problems, right? So there's a really broad swath, obviously, of different types of marketing problems that can be approached in kind of some of the ways that we've talked about today. The possibilities are really endless here. As long as you have customer data, you can apply these types of techniques to uncover all sorts of new information and patterns that you didn't think existed, or to build better strategies for your business. So don't let that customer data go to waste. It's extremely valuable. I think these case studies highlighted that. And we have every intention of doing this for a ton more clients in the future. So thank you everybody for joining. We're going to be open for questions. I know we're kind of close to time here, but if anybody in the audience has questions, feel free to raise your hand. We'd be happy to talk with you.